Hello and welcome to our next section in Chapter 2 for Reasoning and Proofs, Intro to GCRs. GCR is, first and foremost, get this into your table of contents, pause the video if you need to, and let's get this title down as well. Intro to GCRs. Now, GCR it's a very unique proof. It's a one-step proof, actually. And GCR is pretty much just an acronym for given, conclusion, and reason. So, GCR officially is a one-step proof that starts with a given, notice I'm going to put given in capital just to emphasize it, has a conclusion, same thing for conclusion, I'm going to put in capital C, and is supported with a reason. So, supported with a reason. And like I said, this is pretty much our intro to proof lesson. So we have proofs that in geometry, in order to prove something, whether it's, these triangles are congruent or what have you, that's a multi-step proof. Here we're going to be doing one-step proofs. So the GCR method is very, very unique. So the method to this is as follows. You have a given, something that is just provided to you. And it's very specific to a diagram. Because it tells you information, okay? And it's hard to tell what information is without a specific diagram. So we have a diagram. Conclusion. Conclusion is what we could conclude. What can be concluded, that's an A, concluded from the given and the diagram. And then the reason. The reason is very, very unique because it is a lot of things. First and foremost, it is mostly written as an if-then. It is mostly written as an if-then, which means it's P then Q. P implies Q. Okay, and this is the kicker. There are some do's and do nots that you should follow. Do not, under any circumstances, use letters or names from the diagram. Okay? And then number two, what you should use is definitions, theorems, or properties. And you'll see what I mean by properties towards the latter half of this unit. So what I'm trying to say here is we want to be for the reason we want to be as general as possible. As general as possible. Okay, and you'll see what I mean with our example. So, let's close this. I don't know why that's been open. So let's get into it. Let's do one example of a GCR. Call this one-step proof. Okay, given BD, ray BD bisects angle ABC. Now, if you recall, givens are specific to a diagram, and currently we do not have a diagram. So what should happen, or what should be given also along with this, is a diagram. So assuming that there is a diagram already given, so here's an angle, here's a ray. This is A, vertex B, C, and then we have D here to make this ray BD. Okay, so now we have a specific given to a specific diagram. We could ultimately conclude what? So we've been doing this for a while now. Well, what is the conclusion of a ray that bisects an angle? We get two congruent angles. More specifically, we could say these two angles are congruent. We could say angle. So let's do it in red because we are ABD. It's going to be congruent to angle DBC. Okay? And then the reason. Now this is the harder part because remember, there are do's and do nots. We do not want to use any letters in this diagram. So we don't want to use A, B, D, or C, or any combination of them to make an angle. For instance, we don't want to call this angle ABD. We do that in the conclusion and the given. Those are okay, but we don't want to do it in the reason. So what we do here is this. I'm going to make this as simple as possible. I'm going to call the given the P and the conclusion the Q, the if and then we're going to write a reason based off of that. So if you notice, BD represents a ray. So we're going to actually call this if array. If array. Keyword here is bisects. So bisects. And then remember, we don't want to be specific. ABC represents an angle. So we're going to say an angle. Notice I'm going to shorthand angle as the symbol angle. The conclusion is the then. So then. And what does this ray do? This ray divides the angle into two congruent angles. So then the ray divides the angle into two congruent angles. And there's your reason. We are literally transposing this entire given in conclusion into a reason. Okay? If a ray bisects an angle, then it divides the angle into two congruent angles. Okay? Remember, this is specific to diagram. And we want to be as generic as possible when it comes to the reason. Nowhere in the reason do I actually mention A, B, D, or C, or angle names. Now, if you want to, and I highly suggest this, if you want to actually name this angle 1 and angle 2, you are more than welcome to do that. And this could be an alternate conclusion, or angle 1 is going to be congruent to angle 2. If, for instance, you don't want to write all of this out, ABD is congruent to DBC, this is a nice way to kind of bypass writing more than you need to. Okay? So either one works. That's why I'm putting the or here. It's a big difference. It doesn't have to be one or the other. You get the choice. The reason would still be the same because a ray is bisecting an angle. It is dividing it into two congruent angles. Okay? All right. So there's your intro to GCRs, our intro to proofs, really. I'm sure you have questions. If you have them, please let me know. And I will see you in the next one. Bye.